Welcome to my video. It's called Things That Rhett Will Forget in the Future, so he needs to make a video. And I don't know if you saw it, but I made a video about the celestial sphere and the lines of longitude and latitude, and I had a good time. But I messed up, right? I'm like, I wanted to get the lighting right. I wanted to get the sunlight from the sun just right. And I didn't understand everything about lighting in VPython, and I don't think I still do, but I think I can get it to work. Okay, so I read the documentation, and I have a sphere here. And so there's the first thing I don't like, but let's just leave it for right now. You know, the default is a shiny sphere. But I want to talk about the lights, because there are lights in this world, this universe. So if we go up here to the code, I just have a sphere. I'm not even worried about anything there. But there's a list of objects called scene.lights. So what I'm going to do is just to print out the length of that. Print length. It's a list. Length scene.lights. And you can see it's 2. It has a length of 2. So let's print out the first. Let's print out the position of the first one. I don't know if it even has a position. It might just have a direction. Yeah, I don't think it does. Let's just see if I print lights scene.lights 0. That's the first one. Dot position. Let's just see what happens there. I don't think it has a position. See, undefined. It has a direction. Yeah, so it does have a direction. So it is a thing. And then, so there's actually 2 lights. There's the distant light and an ambient light. I think that's what it is. So the first thing that we can do, let's turn this sphere into something nicer. Let's say texture equals textures.earth, because that's what I want. Let's just give it a name. Earth equals sphere, position equals vector 0, 0, 0. Radius equals 1. I'm just going to call it 1. Don't really care. Texture equals textures.earth. And then wrapping their line, shininess equals 0. Let's make this whole thing a little bit bigger so you can see it. Okay, run that. So there's my non-shiny textured earth with the wrong thing, lights on it. So the first thing I want to do is to delete the lights. Let's see if I do this. If I say scene.lights equals lights, is it lights? Yeah, equals an empty list. So I've deleted the lights. And there you go, no lights. But you can still see the earth, right? But it just doesn't have any lights on it. So it's because there are 2 lights. So I need to change the color of the ambient light, which does not have a location. It's everywhere. It's like the background radiation for the universe. But we can turn it off. I can set its color. I can change its color to whatever I want. The color is a vector in VPython, and that vector has a red, green, and blue value. So you can pick a value. Let's just for fun, let me show this. What's it called? Scene.ambient equals color dot yellow. So that's the yellow color. Let's just see what happens then. And see there. Now I have a background ambient color of yellow, which I don't want. I want it to be black. I want to turn it off. Turn it off is black. So black is the color vector, vector 0, 0, 0. Now I can run it, and there are no lights. There is an earth there. Can you not see it? No, you can't see it because there's no lights. Okay, that's exactly what I wanted to. Okay, now I'm going to add in a distant light. So that would be, I'm going to give it a name. L1 equals distant underscore light. Now I can give this a direction. This is the direction that it comes from. So it doesn't matter what values you have here. All that matters is the direction, right? Because it's distant. I already said it's distant. So I want it in the negative x direction. So I'm going to say vector direction equals vector -1 0, 0. And I lost a parenthesis there. Let's do that. And there you go. That's what I want, right? So now I have my light source over here. You can see the Earth. If I rotate it, you know, you can rotate the whole camera. We're rotating the whole camera. We're not rotating the object. You can see that we're rotating the camera because now I'm looking at the Earth like that. That's what I want. Now, it is a little bit like, you know, not perfect. So, and that's fine. I guess that's fine. We can fix that. But what I want to do now is to model the motion of the sun over the course of a year. So what I'm going to do is just move that distant light source up and down, north and south pole, right? And this will model noon. It'll be noon at each point of the day, and for each day of the year. That's what I'm going to do. That's what we're going to do. Okay. So let's call this tilt axis. I'm just going to call it tilt. It's going to be 21 degrees times pi over 180, right? Because that's the axis of the tilt. But what I'm going to do is I'm going to keep the Earth stationary like this, and I'm going to move the sun up and down like that, which is the distant light source. Okay, so the other thing I'm going to need a time, so I'm going to animate this, time 0, a time step of, I'm going to use a time step of, what did I do before? I did 10 hours. I don't even know why I did 10 hours. So let's say 10 times 3600. Everything's in seconds because I think in seconds. It doesn't really matter. You don't have to do it that way. And then I need the time for a year. T year is going to be 365 times 24 times 3600. 3600 is the number of seconds in an hour. What am I going to do now? Okay, let's see. So now I'm just going to make a loop while t is less than t year. And I'm going to have to do this before I forget. T equals t plus dt. Now what I want to do is just to move that distant light source. So to do that, I need this rate 100. L1 dot direction equals vector. Okay, so I still want it in the negative x direction, but I'm going to move it up and down. So I'm going to say this is going to be -1, and then the up and down is going to be the angle, the tilt angle, times cosine omega times t. So omega is the rate that the Earth goes around the sun, so we need that up here. Omega, which I use W because there's no omega, it's 2 times pi divided by t year, right? That's the rotation rate. And you know, you don't really need to do it in exact details out, but when I do it this way, I have the numerical values. I think this will run now. Let's just see. Nothing's happening. Oh, because I didn't put this as a vector. That was silly. There you go. You can see that this terminator, you can kind of see it, is rotating up and down because we're looking at it from the side. Now, I do want to add in a couple of effects just for fun. I want to put the equator, because I think that will make it look better. And then I want to put the Arctic Circle and the Antarctic Circle, or what's the Antarctic Circle called? Well, I want to put circles up at latitude of not 21 degrees, 90 minus 21, and negative 90 minus 21. And that's the region where at some point in the year it will be completely dark, and then at some point in the year it will be completely day, right? That's that max and min thing right there. So let's just go ahead and add these things up there. Let's do with the equator. That'll be the easiest thing. We'll do one thing at a time. So the equator is a ring. The position is going to be at the center of the Earth, so vector 0, 0, 0. The radius is the radius of the Earth, which I have as just 1. Right here I said it as 1. And then I need the axis, which is the orientation of the axle, and that's going to be in the y direction. So it's vector 0, 1, 0. You don't need, doesn't matter what value that is. And finally, I need a thickness. Let's do 1 over 200, and let's just see what that looks like. Okay, so there's my equator. I'm pretty happy with that. Now, I did this before. I did lines of latitude before. But remember, I need to go move it up and 1 sine theta, right, where theta is going to be pi over 2 minus the tilt angle. And then it's going to have a radius of cosine theta. So let's do that. Let's just call it the Arctic. Tilt, right down here. Arctic. I don't know why I always misspell that. Ring position is going to be equal to vector. Oh, let's write up here theta, just to make things easier. Theta is pi over 2 minus tilt. So the position is going to be vector 0 sine of theta, 0. The axis is going to be equal to, it's still in the same direction, 0, 1, 0. The radius is going to be equal to cosine theta. And then the thickness, let's put the thickness at 1 over 200. Yeah, there it is. And you can see complete nighttime. I like that. Now, you can actually, this is sticking up a little bit from the Earth, so you can see it. Also, it's shiny. You could change those properties if you want to. You could even make them emissive so they glow, but I'm not going to do that. Let's just go ahead and make our circle for Antarctica. So I'll call this no bears, right? Because remember, that's what Antarctic means, no bears, because there's no bears in Antarctica. And it's the same thing right here, so I can actually just copy this. It's exactly the same, except it's no bears, not bears. No bears, and it's going to be equal to negative. And then that's good. Now it's summer down there, and you have day all the time. And I'm not rotating the Earth. You could rotate the Earth, but I mean, it would just go so fast that it would just be kind of silly. And I don't really want to do this. So this is like a picture every day. Let's just do one other thing. I want to put a spot on the Earth where the sun is at noon. Let's just see what that looks like. So let's call this sunspot. I'm just going to call it spot. Spot, and let's just do it as a sphere. Position is going to be equal to, okay, so here the position is going to start off at the negative. It starts off at the negative, yeah, I think it starts at position is going to be r, which is 1. So vector negative 1, 0, 0. The radius of my thing is going to be, let's say, r over 50. Let's see what that looks like. Color equals color dot yellow. And then let's just do this one other thing. Let's leave it make a trail and see what that looks like. Now, I'm not moving yet. I'm just checking the size. And you can't even see it. I don't even see it. Did I mess up? Let's see, run that again. Oh, yeah, make trail. Oh, equals true. That's what I did. Where did I do that? Make trail equals true. Oh, it stopped again. Can't find R, because there's 1. 1 over 50. There it is. Okay, there's my dot. Now I just need to move that up and down. So how am I going to do that? I have this direction of the distant light source. And I want that dot to be facing towards that. So what I'm going to do is to just use that same vector right here. And then I'm going to say spot.pos equals that vector. Norm. So it's actually 1 times norm, because I don't want it to go off the surface of the Earth. And norm makes a unit vector. I think that'll work. Now, this is just going to move up and down. Oops. There it goes. Yep. And this is that analemma, what's it called? Where you see on the globe this figure 8. Mine's not a figure 8 because I have a circular orbit for the Earth, but you could see how we could start to make that, and I think I'm probably going to have to do that now, but not now. I think this is good enough. Really, I wanted to focus on how to make the lights move, and let me run this again so I can see that. There we go. That's pretty cool. I could put like a stick there, that'd be kind of cool, but I'm pretty happy with this whole thing. The most important thing is this. Oh, I could add, I'm going to add one more thing. I'm going to add a line for the terminator, because for me, no, I'm not going to, but you could. You could add another ring right here that would rotate and show exactly where the terminator is, the difference between day and night. But I think this is good. Number 1, delete all those lights. Number 2, set the ambient light color to 0, 0, 0, and then you're good to go. So this would be great too for looking at phases of the moon. That's pretty cool, right? Because you could make the moon, and you could do a whole bunch of other great stuff. So this is for me. It's not for you. This is for me when I forget. So you're welcome, you, me, which is in the future, and I'll talk to you guys later. Oh, this code will be down below.